If you have a variable frequency drive controlling a motor and you need to remove power from that motor quickly for some emergency, where do you put the disconnect? The safety guy will tell you here because it'll shut off power to the motor the quickest. The hardware guy will tell you here because you don't run the risk of damaging the drive. So which do you choose? The good news is you don't have to worry about any of that with the GS4 drive because Safe Torque Off is built into the drive. It quickly removes power from the motor via two independent circuits that bypass the processor and shut down both the line drive and the gate drive to absolutely ensure that the output transistors can't drive the motor. Let's walk through a quick example so you can see how to set it up. Typically, you would have an e-stop button with two normally closed contacts going into a safety relay. The relay is then wired into the Safe Torque Off inputs on the drive, which are these two red terminals, so they're real easy to find. Remember, the STO circuitry is hardwired. It can't be turned off. So the only way to get the drive to operate is to force both STO signals to 24 volts. These jumpers that come pre-installed do just that. They tie the STO signals to plus 24 volts and the STO commons to the e-stop common. To implement STO, you just remove those jumpers and wire the STO signals to one side of the safety relay and the plus 24 volts to the other side, and leave the commons connected with the shorting jumper. Or if you want to use your own external supply, delete this wire, add your supply here, remove the commons jumper, and wire the commons to the other side of the supply. The only thing left is oftentimes you'll need for the drive to tell the controlling device what the drive status is. You can do that by wiring the Relay 1 output to the safety relay and setting parameter 317 to make Relay 1 an auxiliary safety status output. Entering a value of 56 says to monitor STO1 and make it normally open. A 57 says to monitor STO2 and make it normally closed. Of course, you can switch the wire to normally open or normally closed to invert that if you need to. And you can also use Relay 2 if you need it. You just set up parameter 318 to tell Relay 2 what to do. The faults are logged just like any other fault in parameters 1104, which is the most recent fault, through 1109, which is the sixth most recent fault. If you read a 72 in one of those, then Safe Torque input number 1 lost continuity. A 76 says you got a normal STO where both inputs went away. A 77 indicates STL2 lost continuity by itself. And a 78 says there was some kind of internal fault to the drive that had nothing to do with the inputs, but the motor was shut down anyway just to be safe. How you reset a drive after a fault depends on which of those possible fault conditions caused the drive to remove power from the motor. This chart in Appendix E does a nice job of explaining the different types of resets. Here's all the possible conditions. In this case, STO1 is connected to his common and STO2 is connected to his common. Everything's great, we're ready to go. On the other hand, if both connections are open, then we have a normal STO condition. If only STO2 is not connected, then that's an STL2 condition. And if STO1 is not connected, then that's an STL1 condition. Exactly what we saw in the fault codes we just looked at. To reset each of those, we use this. If everything is normal, there's nothing to do. If we have a normal STO shutdown, then we just fix the fault, that is, get both STO signals at 24 volts, hit the reset button, and cycle the run command. If we get one of these STL conditions, then we have to power cycle the drive instead of pressing the reset button. Of course, if there's an internal drive fault, you can't reset it. There's two other parameters you need to be aware of when running STO. First, do you want the STO alarm to stick around until you clear it, or should it be automatically cleared when the alarm condition goes away? The default is it'll stick around, or be latched. This only applies to the normal STO fault. The STL1, STL2, and STL3 faults are always latched. The timing diagrams in Appendix E show exactly how all this works. The second thing to be aware of is if run is enabled, do you want the motor to start up as soon as the fault is cleared? The default is no. The drive has to see a run command cycle from off to on before it will restart the motor. In summary, wire the two STO signals to the drive using the internal supply or an external power supply, wire the feedback relay, and configure it via parameter 317 to be a safety output. The type of alarm is viewed just like any other alarm in parameters 1104 through 1109. You can also set if you want the STO alarm latched or not, and if you want the motor to start back up as soon as the STO condition is cleared. All of this is covered in detail in Appendix E of the user manual. So with Safe Torque Off built into the GS4 Variable Frequency Drive, you don't have to buy the external disconnects, you don't have to spend time wiring them up, and you don't have to allocate space for them in your cabinet, all of which saves you time and money. Click here to learn more about the GS4 drives, here to learn more about Automation Direct's free support, and click here to subscribe to our video channel so you're always up to date on our latest tutorial videos.